Hello everyone, today we have a really interesting equation with square roots. We have square root of a plus square root of minus a equal to 32, and we need to find our a. You can also write your solution down into the comment section and then we will check our answers. Okay, so first of all, let's subtract this square root of minus a from both sides. As a result, what do we have? We have square root of a on the left side, and on the right side we will have 32 minus square root of minus a. This is our first step. We just subtract it from both sides. What we're going to do next, right now, let's square both sides. Let's raise these both sides to the power 2. As a result, what do we have? We have square root of a raised to the second power equal to 32 minus square root of minus a to the second power. Okay, so we are going to square our both sides. Right now on the left side we can easily cancel this square root sign and these two. As a result, we have only a on our left side, and on the right side we have a basic formula. We have a minus b to the second power, so we squared it. As a result, this is our basic school formula: a squared plus b squared and minus 2ab. Alright, so let's apply this formula right here on the right side. As a result, what do we have? We have 32 squared plus square root of minus a to the second power, so square root of minus a, we're going to raise this to the second power, and we have minus 2 times a times b, so 2 times 32 and times square root of minus a, minus 2 times 32 and times square root of minus a. Right now let's simplify this expression. First of all, this square root and this second power we can easily cancel, and we can easily raise this 32 to the second power, so 32 square equal to 1024. As a result, on the left side we have a equal to 32 square equal to 1024. Right here we have plus minus a, and we have minus 2 times 32 equal to 64, so minus 64 times square root of minus a. Right now we can easily multiply plus times minus, so as a result the final sign will be negative, so as a result we have a equal to 1024 minus a and minus 64 times square root of minus a. So after this raised into the second power, we have this expression. What we're going to do next, let's add to both sides, let's add this a. So as a result we cancel it from the left side, so as a result we have 2a on the left side. So just look at this explanation. So we have a plus a, so we just bring this minus a to the left side with the positive sign, so we have a plus a equal to 1024 minus 64 times square root of minus a. Alright, so right here on the left side we have 2a, so we have 2a equal to 1024 minus 64 times square root of minus a. What we're going to do next, right now let's factor from here 2, so as a result we will have 2a on the left side, and on the right side we can easily factor 2. As a result, in our parentheses we have 512 when we factor 512 minus 32 times square root of minus a, 32 times square root of a minus a. And right now let's cancel these two. We can easily do this because this is our multiplication, so we can easily cancel these two. As a result, we will have a equal to 512 minus 32 square root of minus a. What we're going to do next, right now let's write this 512 on the left side, so let's bring this 512 from right side to left side but with the negative sign. Okay, so as a result we have a minus 512 equal to minus 32 square root of minus a. So we just write this 512 on the left side. Right now let's raise both sides once more to the second power. Okay, so let's square our both sides. So let's square our both sides. As a result we will have a minus 512, we're going to raise this to the second power, equal to minus 32 square root of minus a. We're going to raise to the second power as well, so as a result we raise our left side and our right side to the second power. Right now basic formula on the left side we had it before, so a minus b to the second power. As a result we have sum of two squares, so we have a square plus 512 square and minus 2 times a, 2 times a, and times 512. This is our formula on the left side, and on the right side, when we have a complicated expression, so expression which includes two expressions inside, so we have 32 and square root of minus a, we need to raise 32, we need to raise both 32 and square root of minus a. So this is our property when we have a times b raised to the power x. This is equal to a to the power x times b to the power x. So we need to raise 32 to the power 2 and square root of minus a to the power 2. As a result, we have minus 32 squared, we raise to the second power, and we do the same thing with this square root of minus a. So times square root of minus a raised to the second power. All right, let's simplify our expression. First of all, let's simplify our right side. Let's do this. So we have a square plus 512 square and minus 2 times 512 equal to 1024a, equal to, right here, minus 32 to the second power equal to 1024, and right here we have a square root. We can easily cancel with this too. As a result, we have only our minus a, so times minus a. This expression is really great for us because this is our minus 1024a. We can easily write this minus in the beginning, so let's do this. As a result, we have a square plus 512 square minus 1024a equal to minus 1024a. And really interesting moment right now, because we can easily write this minus 1024 on the left side, on the right side, with the positive sign. So as a result, we have a square plus 512 square equal to minus 1024a and plus 1024a from the left side. So plus 1024a, and right now minus 1024a and plus 1024a, so we can easily cancel our 1024a, and as a result we have a square plus 512 square equal to 0. So right now we can easily find our root. First of all, let's write this expression on the left side. So as a result, we have a square equal to minus 512 square, and right now let's take square root on both sides. As a result, we have square root of a square equal to square root of minus 512 square. From here we can easily cancel our second power and square root sign. As a result, we have on the left side we have our a, only our a, equal to square root of minus 512 square. So we can easily write this minus 512 square as minus 1 times 512 square. And right now the basic property, we had it before but with multiplication, so when we have a product inside of a square root, we can easily take square roots of our first expression and of our second expression. So as a result, we can easily split it. We can easily write it as square root of minus 1 times square root of 512 square. This is very basic thing because we can easily cancel our square root sign and these two, and square root of minus 1, this is our complex unit, this is our I. So as a result, from here we can easily say that our a is equal to plus minus 512 times I. This is our answer to this question. So as a result, we have the root with the positive sign and with negative sign, because we take square root, so it can be positive, it can be negative, so we're considering it as a two root. So as a result, our a first equal to 512 times I, and a second equal to minus 512 times I. And this is our first method. Right now I'm going to show you the second one, so I hope you understand this method. You can also write a question into the comment section, and right now I'm going to show you the second method, which is also really great for this question. So just look at this second method. So let's look at this second method to this question. Here's our question, and right now I'm going to show you the second method. Maybe this is a little bit easier for us, but let's see what will happen. First of all, this square root of minus a, let's write as square root of minus 1 times a. So let's do this. As a result, we have square root of a plus right here inside our square root sign we can easily write it as square root of minus 1 times a and equal to 32. Right now we can easily split it. As I told before, we can easily write it as square root of minus 1 times square root of a. So as a result we have square root of a plus square root of minus 1 times square root of a equal to 32. Alright, and this square root of minus 1, this is our complex unit. We can easily write it as I. Okay, so this is our I, this is our complex unit. As a result we have square root of a plus I times square root of a. I times square root of a equal to 32. And right now we can easily factor from here our a as square root of a. So as a result we have square root of a, and inside parentheses we have 1 plus I. 1 plus I equal to 32. Right now let's square both sides. Okay, let's do this. Let's square both sides, and as a result we will have we're gonna square our left side. So as a result we have square root of a times 1 plus I to the second power equal to 32 to the second power. Okay, so we're going to square our both sides, but with the plus minus right here because we squared it, and this expression on the left side can be positive, can be negative. Okay, so first of all, this expression, when we raise to the second power, we need to raise our square root of a to the second power. We need to raise both expression to the second power times 1 plus I to the second power. So we're going to raise this expression and also this expression to the second power equal to plus minus 32 squared. Okay, right now this expression equal to a, we can easily cancel our square root sign. As a result we have a times we have a plus b to the second power. We're going to square this left side. As a result we have 1 plus 2i and plus I square equal to plus minus 32 to the second power. Right now I square equal to minus 1. Okay, I square equal to minus 1. This is our complex unit, and as a result right here we have, instead of this a square, we have minus 1. So we have a times 1 plus 2i and plus minus 1 equal to plus minus 32 to the second power. Okay, and right now we can easily cancel this one and this one. Okay, we have 1 minus 1 equal to 0. So we can easily cancel it, and we can easily raise this 32 to the second power. As a result we have a times 2i. Okay, a times 2i equal to, we have plus minus 32 square equal to 1024. What we're going to do next, right now let's divide both sides by this 2i. When we divide it we will have only our a on the left side. Let's do this. So we have a equal to plus minus 1024 divided by 2i. As a result we can easily divide 1024 by 2. We have plus minus 512 divided by I. And let's multiply numerator and denominator by I, because we don't have it in our denominator then. Okay, so let's multiply right here by I and right here by I. This is our I squared, this is our complex unit, which is equal to minus 1. So we are talking about only a swap of signs. So we have plus minus, minus plus, so it's changed nothing for us. We are talking about two roots, plus minus 512 times I. This is our second method, also really great method. So right now let's write our answer to this question. We have a first equal to 512 times I, and a second equal to minus 512 times I. This is our method. We have two roots, and right now I'm going to show you the extra method with inequalities. So we can easily say that square root of a need to be positive. So this expression inside our square root, looks like our third method. Maybe someone interested in this inequality method. So we have square root of a plus square root of minus a equal to 32. And this method is not good for us. It tells us only when we have real roots or complex roots. So first of all, this square root of a need to be positive, so a need to be greater or equal than 0. And this expression is also need to be greater or equal than 0. So minus a need to be greater or equal than 0. But when we multiply this second inequality by minus 1, as a result we have the same beginning. We have a is greater or equal than 0, but the second inequality, we will have a is less than 0. Okay, so when we need to change this sign in another way. Okay, so we will have a is greater or equal than 0 and a is less than 0 or equal than 0. So from here we can easily say that our a need to be equal to 0. One and only way that this equation will have real roots when a is equal to 0, but when we plug in it, we will have square root of 0 plus square root of minus 0 equal to 32, which is absolutely incorrect. So in this method we can easily say that this equation have complex roots, only complex roots. Okay, this is like an extra method just to check when you have real number roots, when you have complex roots. This method is only great for this assumption. Okay, so this is my explanation to this question. I really hope you understand it. You can also write a question down into the comment section, and see you in the next videos. Have a great day.